Today we're going to focus on section 9.5, congruence, and our objective is we will find corresponding parts and identify congruent triangles. So the first thing we need to look at is what congruent is. Congruent means that the polygons have the same size and the same shape, just like these two right here. So this triangle is just a reflection of this triangle. Now down here is something called our congruency statement. What our congruency statement tells us is what parts are congruent. So for instance, our congruency statement can tell us that A is congruent to E, that B is congruent to F, and C is congruent to D, which would match up with our picture that we have right here. We can write congruency statements using what we have above. So we actually don't even need the picture. We could say that angle A is congruent to angle E. We could say angle B is congruent to angle F, and angle C is congruent to angle D. Now the neat thing is, aside from the angles, we could also say that certain sides are also congruent. So if we took the angles away, we could say that AB is congruent to EF. That's because they're both the first two letters. So we could also say AC is congruent to ED. And we could also say AC is congruent to ED. Now I keep drawing those funny little squiggly lines with the equal sign. Remember that that symbol means congruent to. If I wanted to say, for instance, AB, and I wanted to know the actual measure, I would use an equal sign. So say I knew that EF was 12. If I knew that EF was 12, I know that AB has to be the same thing. So if I wanted to find what AB is equal to, not congruent to, I could say 12, because I know that it would be the same as EF. The same goes for the angles. So for instance, if I knew that angle A was 50 degrees, and I wanted to know the measure of angle E, again, we're going to use our equal sign instead of our congruent sign. And because I know from my congruency statement that A and E are the same, I know that the measure of angle E is going to be the same, 50 degrees. So what's neat about the congruency statement is you don't even need a picture. So if we were to name the corresponding angles again, it would be angle X is congruent to angle Q, angle Y is congruent to angle T, angle Z is congruent to angle V. Those are all of the corresponding angles. The corresponding segments, same thing. XY congruent to QT, YZ congruent to TV, and XZ congruent to QV. Remember, this is the congruent symbol. An equal sign would ask us to find the actual measurement. Now in this triangle right here, if we wanted to find angle Z, we have to know that all of the angles of the triangle are equal to 180. So essentially, 30 plus 40 plus Z equals 180. So when we add them all together, we get 70 plus Z equals 180. And we can subtract 70 from both sides. We get Z is 110 degrees. Now, if we go back up to our congruency statement at the top, we know X and Q are the same, Y and T are the same, and Z and V are the same. So if we wanted to find the measure of angle Q, it's the same as X. So we go to our triangle, X is 30 degrees, therefore Q would be 30 degrees. This is what we'll get to as well, is in order to prove triangles are congruent, we have to use certain names. These are like a three-step reason for why something is true. Think about if you wanted to explain that your brother or sister was being mean to you, and you could give 3 reasons to prove that point. That's essentially what we're doing with these triangles. We're saying, I have an angle, a side, and an angle that are congruent, so the triangle has to be congruent. I have a side, an angle, and a side that are congruent, so these triangles have to be congruent. And last, if you have a side, and another side that are congruent, both triangles are congruent. So think again, like if you're trying to prove something, you give 3 reasons and it will probably hold true. That's what we're doing here with triangles. So let's look at this triangle, and what we're going to be doing here is what I like to call a little baby proof of why the 2 triangles are congruent. This is real math right here, actually proving things that exist. So we know that first of all, we can write down reasons of things that are marked. Wn has to be congruent to Nr. The hash marks say so. Now the angles, these 2 are both right. Angle WNB has to be congruent to angle RNB. They're both right angles. Now the last one is a little bit tricky. The 2 triangles share that side, so it has to be the same. BN is congruent to BN. It's congruent to itself. So now we have 3 reasons. Can we prove that the 2 triangles are congruent? Yes. We have a side, an angle, and a side. So it's going to end up being by side, angle, side. But we need to say triangle blank is congruent to triangle blank. So if we said WNB for our first triangle, we need to make sure all the angles match up. W matches up with R, so it has to be the first one. N matches up with itself, and B matches up with itself. This is your whole answer right here. Not just this last part, but the whole entire thing. Let's take a look at this one right here. We got 2 triangles, and it's actually very clearly marked that all the sides are the same. So all we need to do are write those 3 reasons. So first reason, AB is congruent to DE. Then the next one, CB is congruent to EF. And then finally, we have AC is congruent to DF. So those are our 3 reasons right there. So we can say by, side, side, side. Triangle blank is congruent to triangle blank. So now we have to actually write a good congruency statement. So we have triangle A, B, C. So what corresponds to A? D does. What corresponds to B? E does. And what corresponds to C? F does. So now we have our entire proof. Remember, this whole thing is your answer. These are your 3 reasons. This is what you're trying to prove, and it's proven by 3 sides. Our last example right here, we need to add some letters to it, so let's just call this A, B, C, D, and E. Now we need to label our angles that are congruent. We can say that angle A is congruent to angle D. That's marked. Now, because there's only one angle at each of these letters, we only need to use 1 letter. But if there were multiple angles, we'd need to use 3 letters. So AC is congruent to CD because of the hash mark. But the last one's a little bit tricky. We can actually mark these 2 as congruent because they are vertical angles. Now we need to name it with 3 letters because C has 2 angles in it. So angle BCA is congruent to angle DCE. Remember, they are vertical. So now, what do we have? Angle, side, angle, angle, side, angle. Let's actually give those 2 marks because they're different angles. And so we can say bi, angle, side, angle. Now we just need triangle blank is congruent to triangle blank. So let's start out with the easy A, B, C, and make sure it's in the right order. A and D are corresponding. Looks like B and E are corresponding. And then C corresponds to itself. So that would be our final triangle congruency statement. Remember, the whole thing is your answer because it's called a proof. It's proving that the 2 triangles are congruent.